Okay, well, hello and welcome everyone to this case study presentation, which will be delivered by Vortex IoT, who we are delighted to have as co-sponsor for this online industry summit. From Vortex IoT, we have Adrian Sutton, founder and CEO, and we've also got Behzad Haravi, founder and CTO. They will discuss the convergence of AI, 5G and Lidar for digital twins in rail. Before we get started, just a brief message for the audience. If you have any questions for the speakers, please ask them in the questions box and we will have a Q&A session at the end. So without further hesitation, Adrian, Behzad, let me now hand over to you. Thank you.
Thank you, Craig, and good morning, everyone. It's a pleasure to be here and very honoured to be co-sponsoring this summit. The title of our presentation is on the slide, so I'm not going to read that, but I'm going to leave you with a couple of thought-provoking factoids as a run into our presentation. So Network Rail has easily well over 150,000 different assets, of which 45,000 have some form of remote condition monitoring capability. There are 20 kilometers of track, of which about 40% is now electrified, and that number is expanding, as we know. There are 30,000 bridges and viaducts, and there are 6,000 level crossings. And of those level crossings, only about 1,000 really form that traditional normal picture which we all see of cars going through gates, etc. There are 5,000 which come with various issues, etc. And there are 2,500 stations. Okay. There are over 18,000 standards and rules to manage those assets. And in a time when punctuality and reliability is the biggest driver of passenger satisfaction, we ask the question of where does continued improvement and efficiency come from? To our mind, digital twins and artificial intelligence has a place. And that's going to be the focus of this presentation, really. And I'll now pass on to Behzad, who will begin that journey for us.
Thank you, Adrian. I would like to start with Lidar, light detection and ranging. Lidar can remotely create a point cloud or 3D representation of a scene or an object by illuminating them through near-infrared laser. And in recent years, development of smart, autonomous and self-driving cars has really fast-tracked Lidar technologies and pushed them into a more than more technology. Exceeding Moore's law's expectation that the amount of transistors in an IC doubles every 2 years and the price for the half of the price. I'm showing you the evolution of Lidar in recent years. From 15 years ago, it started as laser ranging, and then to about 10 years ago, spinning Lidar, first time used for autonomous vehicles. And then by that time, Lidar was using time of flight, which is using pulse laser to calculate the distance to points of objects. And now in recent years, we're moving towards MEMS mirror Lidar, which is an array of small tiny mirrors that vibrates and creates and steers the laser light to create that point cloud. And the future goes towards coherent Lidar, where narrowband filters is used to block the incoherent signal, which actually advances the precision resolution, and Lidar becomes more impervious to sunlight glare and interference with other devices. Also, we can measure velocity directly and simultaneously. Next is silicon photonics Lidar, which will be available in the next few years. And here we'll have a completely solid state Lidar, which will make it more desirable for rail applications. Silicon photonics also uses phased arrays to steer the laser beam, basically. And it future holds for quantum Lidar, where even single photons can be detected and traced using quantum entanglement, and that will enable us to see through very dense fog. AI, artificial intelligence, as Gartner says, AI is hot and hyped. In the last year only, the percentage of enterprises that has deployed AI has quadrupled almost, from 4% in 2018 to 14% in 2019. And this shows basically AI is delivering results and profit. AI can cover diverse aspects: computer vision, anomaly detection, pattern recognition, prediction. In computer vision for rail, we can create that 3D representation, object detection and classification, for example, to detect human intrusion. In anomaly detection, we can detect outliers and gradual changes in the infrastructure, degradation, even accumulation of sand, snow, or leaves on rail. And pattern recognition, we can identify dynamic behavior of human behavior, detection of cable theft attempts, suicide attempts on rail. And finally, prediction, failure prediction for assets, which enables predictive maintenance. And thirdly, 5G, the upcoming 5th generation of cell networks coming in different frequency ranges, from sub-gigahertz for dense buildings, dense number of users, and large events, to higher frequencies, sub-6 gigahertz for smart cities, and even to millimeter wave, which offers a really high bandwidth which is suitable for transport infrastructure. And it comes with cool features like beam steering, massive MIMO, and dynamic spectrum selection. Can reach to real-world upload speed of 100 megabits per second, 200 megabits per second of download. Which actually can promise a connected future for rail and can enable real-time IoT. So these three technologies coming together and converging towards a common aim to develop digital twins for rail. A digital twin is a accurate and real-time digital and virtual representation of an object, a process, or a system. And it can simulate virtually the physical device or system. It requires a 3D representation of the object or system or material. Lidar can help here. Sensors on physical world like IoT sensors. Accurate models, mechanical models, electrical, thermodynamic, aerodynamic, which are based on explicit rules, basically laws of physics and algorithms. And also causality links between the system states and features, which are based on implicit rules without relying on explicit algorithms, which here AI can help. But none of this could be realized without a connectivity and low latency and real-time, high throughput, reliable communication, which creates the backbone wireless infrastructure for this. Here I'm showing a legacy cycle of operations in rail, starting from survey to analyze, and then a team of engineers to design, construct, deploy on rail, and then over time operate and maintain, and finally improve and go back to complete the cycle. Digital twin here can come and create a parallel world here and help us to, instead of survey, measure on the digital twin. Instead of analyze, we use AI, and instead of design, model, and then to integrate instead of construct, simulate instead of deploy, emulate instead of operate, and then validate. I'm rhyming here a little bit. And then optimize instead of improve, back to measurements. Adrian, you're muted.
So as we can see, the digital twin paradigm and the convergence of those technologies is something that is very much a reality. And like all change, it's somewhat iterative, and I think it's fair to say that Network Rail have played their part in this and have made significant improvements in the last 10, 15 years. we've developed this particular rodeo product with Network Rail in the past 2 years, and we've done so as part of the DFT's Accelerating Innovation in Rail program, which has been administered by the Innovate UK, but has put us on Network Rail together to develop rodeo to create this digital twin. So not so much a paradigm shift as an iterative move and a product that we can see is going to deliver significant value into the rail sector, both in the UK and globally, and we have significant interest around that. I'm very pleased to say that we've also got the support of not only Network Rail, but the Transport for Wales team, and also the Network Rail infrastructure team in Wales. So as the program name suggests, Accelerating Innovation in Rail, Network Rail themselves and DFT are very serious about change, and with rodeo, we're seeing significant opportunities, and in the actual circle which Bazad just walked through, we can see how we play our part in that, and in detecting sort of intrusions, obstructions, and the degradation across that rail infrastructure. One of the things that really caught me is there are over 18,000 standards and rules for managing assets. But in talking to signalers, we can see very simple things. Some of the rules are in that we've got a sheep on the line here, but one of the key rules is if there are 4 sheep on the line, then the train goes on regardless, and the sheep become casualties. But 5 sheep, the actual rule says that the train should actually stop. But there's just one sort of small rule. But how do you begin to manage them across a 20,000-mile network with all those assets which we coloured across the top of the presentation? So we're very excited and very proud of this product, and in the people that we're working with at the moment, there's a significant amount of excitement, and the same is true globally. Whereas we're working with people in Saudi and UAE and Namibia, where instead of sheep, it's sand and camels that are the problem, and they're big problems to them as well. Okay. So it's no little sense of pride that we secured further funding and support from DFT in the past couple of months, we're proud to be amongst the first of a kind 2020 innovations that were recently announced, and there'll be 2 pilots over the next 6 to 9 months running with TFW and Network Rail respectively. So change isn't always iterative, and it's fair to say that at Vortex IoT, we're kind of demonstrating the commitment to change by DFT and Network Rail, and along may that continue. So to continue and perhaps put a bit more realistic flavour to this, I'll now hand back to Bazad.
Yeah, thank you. So as Adrian mentioned, Rodeo is a product, railway optical detection of intrusions and obstructions. We use it as a digital twin enabler for rail. And the 2 case studies we're pursuing this year, one is a station in South Wales, Bargoed Station, where we use Rodeo for detection and monitoring passenger behavior on platform. The device comes with integrated AI and can create that digital twin, and it has 5G also for connectivity. So it creates that digital replica of the station and the points of interest and the area of interest. And it can, using the point clouds, it can detect objects and track them and report security-related events, and also detect and classify intrusions and obstructions that can happen near the platform around the station. Secondly, the other case study is a tunnel. We're using Melton RIDC Center to test this. Grimstone Tunnel at Melton, which comes with 5G connectivity as well. We use Rodeo to again create that digital twin of the tunnel itself, the rail assets inside the tunnel, We can track and monitor leakage of water, accumulation of water inside the tunnel, animal intrusion, and finally the digital replica or digital twin of the assets inside the tunnel to track for preventative maintenance. Coming to the final point, how does the future of intelligent rail look like with pervasive digital twin paradigm? The cycle starts with sensors, IoT sensors, Lidar and camera devices on physical rail, sensing and collecting data, communicating through 5G. It's important, it's in real time and with low latency to be processed over the cloud on the digital twin using the AI. And then using predefined models, simulate and then analyze again using AI and statistical tools. The information then can be fed back through 5G, again in real time, back to control centers for rail and optimize, and then the cycle continues. In the digital twin side, digital intervention, data processing happens, and AI-driven analytics. Also similar to building information management, modeling, we can have rail information modeling, visualization, and can enable new technologies like visualization in VR or AR, virtual reality for an augmented rail workers, and also autonomous robots and RAVs. The benefits it can bring better visualization using this visual simulation, virtual models for error and failure detection, improving availability of rail assets, lifecycle rail infrastructure management, better coordination, collaboration, faster project delivery, more informed decision, risk mitigation and having fewer accidents in sites, improve rail worker safety, and finally, optimization of costs and schedule. That, Adrian, concludes.
So, the convergence of technologies to create a digital rail in a bit of a canter there, but I hope you all found that slightly entertaining, and very happy, Craig, to take questions or however you wish to play the next part.
Yeah, of course. Yeah, fantastic presentation there. Thank you very much. Great presentation, impressive insights into the rise of digital twins and how this fits in with the intelligent rail of the future, which is such a key topic at the moment. So thank you. So yeah, let's spend some time on some questions. So one through from the audience here, Adrian. I know that you you mentioned there about the technology with regards to environments such as sandy environments. So somebody's asking, can you combine sand detection with fencing breaks? With livestock infringements and trespass. So I know that you touched on it, so perhaps just explain a little bit more about that.
Yeah, I think the beauty of the Rodeo product that we developed is the versatility of the 3D Lidar and artificial intelligence. So we are currently sort of, one of the problems we have is what use cases do we focus on? So we focused on degradation, so that's changes in the track infrastructure over time. That could be geotechnical, and that could be as simple as sand coverings. So in the case of a fence breakage, then as perhaps Bazard's final slides where he was mapping out the station, we were able to collect sort of and learn what that environment looks like. So if there is a break in the fence, then our picture changes over time, and we can detect that. So it doesn't require you know, a CCTV camera or someone to go physically visit there. There has been a change in that environment, and we can relay that in real time. Bazard also talked about upfront in his about pattern and behavior recognition. So we are able to detect whether if there is someone trespassing and go into that fence, for example, to damage the fence or to climb over that fence, then we can begin to detect that. And that's something we're doing with the Network Rail Wales team, where the cable theft is often from a yard, a stockyard, where people are beyond the fence or walking dogs every day. But there's also some cynical behavior, and then we can begin to detect the behavioral patterns in that, and therefore, yes, the security use case is something that we can do within the scope of that project. And you can combine them with others. So I think it's the versatility and the sheer number of use cases that you can get from a single device, which is what's powerful. And when augmented or integrated with other technologies like fiber optic acoustic sensing is very much in the fray at the moment, or CCTV, you get a very rich data set, which becomes ever more accurate because you're validating multiple data sets against each other to create an actual picture. Because some of these products or technologies are easily spooked. So often it's not about what you're detecting, but that you're not raising false alarms or false positives or false negatives, as the industry term is. So if I was to round that all off, I'd say versatility and number of use cases are quite infinite to a certain extent.
Excellent, fantastic. So another question here around the solution to be deployed at stations and platforms, and detecting anything untoward. The picture that you showed on your slides showed quite an empty station. So how does the technology work when stations are overcrowded and busy in detecting what's going on? So the precision of the technology, how does that work?
Yeah, so the point cloud that the technology creates, it can detect multiple objects and can track multiple objects. There's no limit on the number of objects basically that it can detect and track. And what we do for busier stations, we will deploy more devices that can look at the station from different angles and different field of views to make sure that we can cover every corner, and track and having basically sensor fusion and data fusion of the point clouds, so it can basically concatenate and accumulate the point clouds and create basically a replica of the whole station and everybody in it and all the objects.
Excellent. So that covers kind of external issues. Somebody's asking, can your product also be used to monitor what's going on inside trains? So onboard technology, is that something that you're looking into?
It's certainly on the roadmap, Craig. We've not focused on it. You know, our priority has been to look at external track infrastructure. We think it was, you know, at times quite poorly served by technologies, and therefore we've looked to the challenges that existed there and developed a product according to that. With regards how you could then use the product internally, then yes, you can. 3D Lidar is often used in very busy shopping centres to detect you know, shopping behaviour and patterns, etc. And we ourselves, you know, we're an IoT company, and during the past few months, we've actually developed solutions that are COVID related, so and help to identify sort of the well, identify, but some form of risk assessment tool to see how many people or the people flow through a particular area, and what is the likelihood then of there being some form of virus threat in that area. Okay, so again, what you're seeing is the versatility of Lidar technology when combined with AI and 5G or other communication technology in order to get that data back very quickly and to do both risk assessments in real time that help you then with the running of internal and external spaces.
Okay, so what about issues around cybersecurity? What more do you think the rail industry needs to do to gain greater insight into handling data and how this impacts cybersecurity? Is there a worry, or is there still a worry, that digital systems are open for attack? How have you worked around issues with cybersecurity?
So, a very good question. So the threat is always there, and it's getting ever bigger. You know, it's critical national infrastructure we're talking about here in the case of rail. So we take that very seriously, and we're working with some partners. And literally in the past 2 months, we've secured or launched another product and secured some funding for that, which is specifically targeted on cybersecurity. Bazad will tell you a little bit about that now, but there are the cybersecurity solutions that we're embedded into Rodio are regarded as best practice and considered very extensive. So Bazad, do you want to say a little about what we do in that area?
Yes, digital twin actually can be a double-edged sword here for cybersecurity. It can itself be a target for security and cyber attacks, but at the same time, it can also help us to understand these threats and to be ready and resilient for them. We use in another project, we use digital twins as a test bed for testing cybersecurity. And intrusion, having an AI-based intrusion model and AI-based defense model for cybersecurity, and they work on a digital twin instead of a real system to create and evolve and get better and create resilience for the system, for the physical system by doing this test on the digital twin of the base. 5G on its own, it's secure, comes with 3GPP standard for security, and but digital twin itself, since it's on the cloud, it's prone to security threats, but we can be ready for it and improve resilience in the digital twin.
Okay, great. So I think we've got time for just one more question, which is around the industry working together with each other and sharing knowledge and experience. Obviously, Vortex IoT is working in partnership with other industry stakeholders. So would you consider knowledge sharing from all parts of the industry key to rail's transformation?
Absolutely. We have a mandate almost that we will partner for success and we will collaborate for success, and we have quite a wide range of partners across the rail industry, because when it comes to IoT, and we've talked about digital twins specifically here and analytics, there's no one vendor's got the answer. It requires an ecosystem approach and a multi-vendor approach to it, and we're very realistic of where we play a part in that. We play a very critical part. We very much see ourselves as data generators and transporting that data from those remote locations where previously data wasn't possible to retrieve or was costly. So we're looking at scalable and economically viable ways to generate that are all important data to create these digital twins or to shine light in areas where previously there was darkness. Okay. Similarly, we know that we have to integrate that data, and the value in that data lies in how it's visualized, how it's then turned into actionable intelligence for the end user, and that end user may be like we are this morning, looking at some screen and understanding what decisions do I now need to make. So we're actually from the edge, or from the network infrastructure, we're sending very intelligent data. So we're classifying. So that's really reducing the latency on the data transfer, but on the ability to make a telling intervention that counts. And whilst we have got very good technology and very good means to do that. The power comes in working together. So anyone on the call or listening in today who wants to reach out and think there's an opportunity to collaborate or work together, then we are all ears and your defenders.
Fantastic, thank you. Unfortunately, that is all the time we have for today. Adrian, Azad, thank you so much. Excellent presentation and some exciting things coming ahead. Just a message to the audience, please check out the exhibitors page on the platform where you can find out more from Vortex IoT and the great solutions that they have to offer. So thank you, and that wraps up the session. So thank you and goodbye.